almost evening. Welcome to Purdue Agriculture and Biological Engineering's presentation. As you might have heard, we've been ranked number one for over 10 years running now. And today you'll hear a little bit about the department as well as the biological engineering program itself. So as I mentioned, we are agricultural and biological engineering with the goal of solving global problems, really. My name is Mohit Verma. I'm an assistant professor in ABE. I focus on the biological engineering side of things. I teach the junior course, ABE 303, which is Applications of Physical Chemistry to Biological Processes. In my lab, we do research on field deployable biosensors, developing different types of microbiomes, as well as soft devices. I also have here with me Dr. Engelberth. Dr. Engelberth, if you want to introduce yourself a little bit.
Yes, hi, I'm Dr. Engelberth. I'm a associate professor in biological engineering. I teach our junior level bioprocess engineering lab. And as far as research goes, I personally look at separations for value-added product recovery of valuable products from otherwise wasted streams. So it's a little bit of what I do.
We also have AB Ambassador, Gabby here. Gabby, do you want to say a few words?
Yeah, hi, I'm Gabby Selvia. I'm a senior in biological engineering on the cellular and biomolecular track. I'm involved in a few different things on campus, along with ABE ambassadors, as you can see on my slide. Some experience I've done undergraduate research in the drug discovery building. I've also studied abroad in Germany in the industrial and microbial biotechnology course. That was an ABE specific study abroad. Yeah.
Cool. And Lori, do you want to say a couple sentences? You keep us all together. You're still muted, Lori.
Sorry about that, everyone. Good evening, everyone. My name is Lori Snyder, and I serve as the academic advisor for the engineering students in ABE. So anything that deals with academic advising, I will be the person that you will work with throughout your time with us. So it's nice to meet you all. Thanks for joining us.
Within the Department of ABE, we have three majors, biological engineering, agriculture engineering, and ENRE. Today, we'll talk about biological engineering, but if you have questions about the other majors, feel free to go to those programs as well. To introduce ABE, So that video itself was from the American Society for Agriculture and Biological Engineers. And if you think about who a biological AB is, a few words that will stick to you will be innovation, global problems, and you'll see that typically we're tackling very big problems from multiple disciplines and trying to come up with solutions, whether that is in the lab or in the field or developing solutions that go from the lab to the field. Within ABE, the biological engineers themselves focus on biological products. So for example, if you look at your screen, you'll see three different types of products. On the left, you have yogurt. In the middle, you have detergent. On the right, you have vaccine, for example, the COVID-19 vaccine. All of these are have something in common, which is that they are biological products, and biological engineers could be working on any of these applications. So for example, in the case of yogurt, you're looking at bacteria that are producing the yogurt or basically converting milk to yogurt. And in that case, how to increase the efficiency of production, and also how do you process the food so that it has the right texture and taste and so on. In the case of detergents, a lot of the detergents today have enzymes present in them to make them more effective. These enzymes are engineered by either microbes or cells, depending on the applications. And finally, with vaccines, as you've seen, for example, for COVID-19, the development has been very rapid. And that's because a lot of the technology has evolved so that we can engineer the vaccine from nucleic acids, and that's how this vaccine was developed. And that's, again, a problem that biological engineers work on, both from the fundamental perspective in terms of how to come up with something new, but also from the scale-up perspective in terms of how do you make sure that the product is repeatable and can be produced at a large scale. To really achieve this, and to summarize, really, biological engineers are practicing engineering for life and building on the principles of engineering and biology. They're tackling problems in food, health, and energy, and contributing to a bioeconomy. For comparison, if you think about the information technology revolution, which would have been in your parents' generation, in the late 70s, you would have had a computer which would have cost thousands of dollars with no internet, no graphics, and that would evolve in another 20 years to like lowering price, but be able to browse the internet. And then currently, obviously, you have under $1,000 smartphones, which are way more capable compared to these previous computers, and they have internet, music, on-demand video, and so on. Similarly, in your generation, if you want to compare the bio revolution or biotechnology revolution, you can think about the late 90s, where the sequencing of DNA was really expensive. For example, around almost $300 million for human genome, and the bioeconomy is in the order of $40 billion per year. Currently, we already have DNA consumer products. You can get a human genome sequence in the order of around $1,000, and the bioeconomy has already grown almost tenfold. In the future, as we're learning how to edit the nucleic acids, DNA and RNA, we can think about what the future possibilities are, and that's one of the areas that biological engineers work in. As I mentioned, using these technologies, we're tackling challenges in food, sustainability, energy, as well as healthcare. To tackle these challenges, within the program, we have different concentrations, which are listed down below, including bioenvironmental engineering, where people can work in, for example, EPA or other not-for-profits or companies. In cellular and biomolecular engineering, you're looking at biotech companies or new developing bio-based products. In the case of food and bioprocess engineering, there are companies such as Kraft and ADM, as well as trying to come up with new products where you're mimicking nature for the purposes of food. There's also the pharmaceutical process engineering, where the focus is more on biological pharmaceuticals, again, a recent example from Lilly is the antibody therapy that they came up with for COVID-19. That's something relevant to this concentration and to this major. If you are also generally interested in biological engineering, but don't necessarily want to specialize in one of these concentrations, you could also just get a degree in biological engineering without a concentration. To distinguish between these concentrations, I would like to invite Dr. Engelberth back and talk a little bit about the courses and the differences between them.
Yeah, thank you. So a lot of our core courses or our core courses are the same between all the different concentrations because we want all the students to have the same fundamental understanding of the engineering principles. However, to differentiate and make sure that each of the concentrations is a little specialized, we have some courses that are better suited for some of these majors. So, or concentrations, sorry. So in the bioenvironmental, students also look at how soils, water, and air interact because all of those parts of the environment that can host microbes, things like that, they all work together. So we need to have an understanding of how some of these environmental aspects work with some of the biological components in cellular, molecular, biomolecular engineering. My gosh, apparently I can't read today. We look at including also process engineering of renewable resources, some biotechnology lab components so that students have an understanding of how some of these techniques are in practice. On the food process engineering, we also include some biochemistry or food science and microbiology to add some of those elements in. And then on the pharmaceutical side, students look more also at pharmaceutical manufacturing, dosage, fundamentals of biology, things like that. So for our concentrations, each of them is very similar in the fundamentals, but there are some specialized courses that have been added in. In each of our majors, we also have practical hands-on experiences, courses for students. So the ABE 325 soil and water resource engineering for the environmental. We have the 226, 227 biotechnology labs for the cellular and biomolecular. I know they, at least in the 226, they isolate a bacteriophage and identify it. A lot of our students also then take the design of electronic systems, and this allows them to see how all of these electrical components and feedback and all these things work together, especially for large processes. It's important. And then we also have the introduction to pharmaceutical manufacturing processes hands-on through the pharmacy program.
And that gives you a good overview of all the types of courses within biological engineering. Now, if we take a step back again to the department, the department itself is recognized as a world leader, and there are many reasons for that, as you might have seen on Purdue's websites. Really, it ranges from different types of research, as well as the facilities that are available for example, there are research ranging from what I've mentioned with diagnostics of, for example, COVID-19 or animal health and so on, all the way to looking at the how do you improve the environment and developing new agricultural technologies. There's also work on entrepreneurship. So starting companies, and when you come up with new ideas, how do you commercialize that technology and actually have an impact in real life, whether that's for farmers or for different types of users. We're also looking at different uses of big data and applying them to sustainable agriculture. How, as Dr. Engelberth mentioned, developing sustainable bioproducts. In addition, the students have the ability to compete in different types of competitions, which we'll mention a little bit later, and participate in research opportunities, undergraduate research opportunities. Finally, we also have a brand new building, which we've just moved into in December, and it's up and running. That's where the classes are happening this spring. It's the first time the classes are happening there. And it's a really nice space. It's a huge expansion compared to what we used to have. Nice space both for classes as well as for research experiences. The ABE building is shown over here, and ABE also offers many scholarships in the order of almost $145,000. About 24,000 goes to sophomores in ABE. The atmosphere itself is very welcoming and collaborative. You'll notice that because the faculty to student ratio is fairly low, so you have a lot more access to the faculty. And even though we're a really good department, everyone is very collegial, and you'll notice that in the atmosphere as you talk to your colleagues as well as faculty and staff. We are part of both colleges of engineering as well as agriculture, which gives, from the student's perspective, there's a lot more opportunities, for example, for scholarships, because you can reach out to both the colleges, and also for experiences, because there are different opportunities in each college. The class sizes are relatively small. For example, in the junior level in BE, there's about 60 students. The ratio of student to faculty is fairly low, which is good. So you have access to faculty for both for advice and also if you're looking for opportunities for research and other competitions and study abroad experiences. I would like to invite Gabby to talk a little bit about the student life in ABE, give a couple examples maybe from her own experience and what she's heard from other members in ABE.
Yeah, some great examples of just what Dr. Burma was talking about. I have gone on a study abroad through ABE department. I had a ABE faculty member take me to a group of students to Germany, and that was really exciting opportunity. The faculty to student ratio is something that like a number doesn't really mean a lot, but I can say that you have direct access to research opportunities with faculty. Office hours are really easy to get some one-on-one FaceTime with faculty if you're struggling with a class. And just the number might not mean a lot, but like just the time and interaction you can get from that is really wonderful. There's also really good ways to get involved. I'm an ambassador, and so this is a really strong program that faculty are even a part of, and so that's really wonderful. And yeah.
Cool, thank you. In addition to that, I'll also add, as I was mentioning, there's a couple big undergrad competitions that ABE students participate in. One is the soybean competition, where typically students are looking at different ways of developing products out of soybean. And every year you come up with a new idea, usually work in a team and compete for a cash prize. There's also the iGEM, which stands for International Genetically Engineered Machines, which is more of a synthetic biology competition where you're looking at, and you're competing internationally. There are teams from all over the world. You're looking at developing new types of synthetic biology tools for different applications. For example, this year, the students were looking at COVID-19 diagnostics. The years before, they've looked at producing different types of biological products. And each year the application is a little bit different. Students also have an opportunity to work at different types of industry. For example, here you can see the example of Ginkgo Bioworks, people either for internships or obviously getting a placement after completing the degree itself, as well as in food industries. Undergrad research is, as we've mentioned a couple of times already, a lot of students are able to secure an opportunity with the faculty, whether that's within the department or even across different departments. For example, in my lab, we have, like right now, we have around 5 undergrad students that are working on different types of projects. And because the faculty do a variety of different research, depending on your interest, you can find out what is going on in the department and see whether the faculty have a matching opportunity. Usually what that lets you do is, especially if you're considering R&D either in industry or looking into academia, that gives you skills to be prepared for those lines of work. As Gabby had mentioned, there's also global opportunities for study abroad. Dr. Engelbert has led one in the past. Do you want to jump in and talk a little bit about your experience?
Yeah, so I developed and led the initial phase of the industrial microbial biotechnology in Germany, where we went to Germany for 2 weeks, traveled around and went to all different types of companies that made things with microbes. Everything from pharmaceutical to obviously beer and wine. I mean, we're not going to go to Germany and not do beer. And we also went to companies that made enzymes for detergents. So all kinds of fun stuff. Obviously, not happening this year and didn't happen last year, but it's going to happen again. And once we can travel the globe, we're going to get back out there. We've had faculty members that take students to China, Thailand, I believe Thailand, if I'm remembering correctly. But we try to make opportunities for our students, specifically for our students, because we want to make sure that they have that experience. But we're also amenable to, if you wanted to semester abroad, to helping you find places that fit well with our program. So we have a lot of opportunities that way as well.
And with all the experiences, both within your courses as well as internships and global opportunities, usually the students go out to work in a variety of different companies. And you can see some examples on the slide here. There you can see examples from the food industry, as well as pharmaceutical industry. Lilly is a big employer, and biotech industries as well. So a variety of different opportunities once you complete the degree, and the placement rates are fairly high too. With this, what I want you to think about is what kind of activities do you see yourself participating in? And that's what we'll open up the questions with. If you have if you want to get involved in, or if you have more questions about the program itself and want a follow-up session, you can sign up here, and we will have your details so that we can let you know when we have more detailed sessions about that. With that, I will actually open the floor to questions. Yep. So you can, depending on, you can either, it's a fairly small group, so you can just unmute yourself and speak up, or if you feel more comfortable, go ahead and just write it in chat. I'm going to stop sharing my screen so that we can see people. Why don't we start with what are the activities that people found most interesting?
I would also like to encourage everybody to turn on your videos if your internet connection so allows. It is so much more engaging when we have an opportunity to talk to you actually face to face. Face to black screens is less engaging, as you all probably know, because this is not your first Zoom rodeo, I'm assuming.
Hey, look at all you.
Come on, don't be shy. As people are trying to find their unmute button, a really quick, my name is Dr. McMillan. I'm a faculty in our department too. I teach in the environmental side. I do a lot of recruiting. So if there are questions on the newer concentration on the bioenvironmental space, I'm happy to answer those as well. This is something that we've recently rolled out, which is a really cool connection between the two parts of our program.
Mm-hmm.
I have a quick question. I know chemical engineering also has a pharmaceutical concentration. What is the difference between biological engineering with that concentration in chemical engineering?
I'll take a first stab at answering this. So the way I like to think about this is that depending on what the pharmaceutical product is, the way you make it is very different. So a lot of pharmaceutical products are actually made from microbes in some way. So these little bitty bacteria or yeast will make the product that we're after. And in order to do that, we need to have a good understanding of the biology and the process involved. Other pharmaceuticals might be synthesized chemicals. So having an understanding of the chemistry and the processing involved is necessary for that. But both are highly relevant and used in the pharmaceutical industry. So both chemical engineers and biological engineers have their place in the pharmaceutical industry, but how necessarily the particular product is made is different. And so we need both areas of expertise. So if you're more interested in chemical synthesis and products made from that, then chemical engineering is probably the route to go. But if you're more interested in manipulating genomes of microbes and having them produce the pharmaceutical in a different way, then biological engineering might be the better track for you. So it's kind of what your interests are and where you see yourself. But both of them are absolutely necessary and have their place because we get our pharmaceuticals from a lot of different places.
And I can speak a little bit to the class experience between the two. The pharmaceutical concentration within chemical engineering will have classes that you take that will pertain to that. But in biological engineering, a lot of our coursework does center on sort of that side, or a lot of our examples we do in class might pertain to that. But they're doing similar examples, just maybe not exactly focused on that, where some of ours might be. But
And Dr. Engelberth, correct me, I'm wrong. And one more thing I'd like to jump in on this particular topic, because I do think there is a distinction. And the main other distinction, I believe, for us in biological engineering is not only are you learning about the microbes and of needing to produce, say, an insulin or a pill, you're also learning to know how to scale up a drug, the kind of equipment you need, the rooms that they produce the various, if it's a pill, if it's a tablet, if it's a liquid, as if it needs refrigeration. You're going to learn a lot about those pieces of the puzzle through biological engineering, because anytime you make a drug, you have the drug, but then it's got to go to market. How do you get it to market? It's got to be scaled up. How does it get scaled up? Various equipment, and how does that equipment operate and run? That's where the biological engineering side. So with our classes, you're going to get into some of those classes that you'll go, why am I taking heat and mass transfer in biological engineering? And it's because of that purpose. Is learning. It's a much broader scope of, say, pharmaceutical process engineering. Okay, does that help? And Dr. Engelberth, feel free to jump in there if I said anything incorrect. But
No, that's all right. So it's all like, it's the processing involved as well as the initial production. So both are needed to really understand how to take it from concept to market.
Okay, thank you. That helped a lot, actually.
Oh, good. Yes. There's a
See a question in the chat. I don't know if that's been answered already.
So the question in the chat is, what are the opportunities in bioenergy and remediation? That's a really broad question. So in bioenergy, that kind of fits in the bioprocessing side. So sorry, my children are yelling, I can hear them. The bioenergy side, we look at a lot of renewable energy. We have the Laboratory of Renewable Resources Engineering in ABE, and that has been a lab focused on bioenergy and bioenergy renewable applications for the past 40 years. So in that bioenergy, there's a lot of opportunities, both on the growing, harvesting, storage, use side, and the conversion, all that side. So there's that. And then remediation, I would think Dr. McMillan might be able to talk a little bit more about remediation. What do you think, Dr. McMillan?
Oh, well, maybe a little bit. Scratch a few brain cells back there. Yeah, so remediation, I teach a course called Soil Microbiology right now, where we're talking a little bit about this. And I think the biggest thing is, you know, some of the courses you take in microbiology are like in a lab. So you take these biotech labs, which are really fascinating, isolating bacteriophages. Well, they're basically isolated from soils. And the reason they're isolated from soils is because soils host a incredible diversity of microbes. And these microbes are kind of adapt and evolve to whatever environment they're in. And the way that we use it for bioremediation is we kind of think of this as like, okay, well, here is a contaminant or an organic chemical that we have never seen before in these contexts of where we can put plants and microbes and amend the soil with really, sometimes simple organics to prime the system to get these microbes to do kind of the hard work of degrading an unknown compound. So it's a lot of microbial ecology, but it's also a lot of trying to understand how microbes function and their timescales and their life histories and how they work together as a community. So it builds into a lot of the context of the basic things you're using. You're just not doing it typically in a tank, but more actually out in the environment.
So let me ask the students who have joined us, what has interested you about looking at biological engineering? You can unmute yourself and just give us a sense of why you're looking at biological engineering. What is it that's of interest to you there?
Is it me?
You
Are you all
all
interested
so
in me?
shy.
I mean, you don't have to say it all at once.
Yeah, you all
I
are
can
very
go first.
You can also type it in the chat, things like I'm interested in drugs, medicine, biotech, renewable energy, making waste products from good stuff. No, the other way around, making good stuff from waste products. I'm just teasing Dr. Engelberth because, you know, it's fun. It's the end of the day for us too, you guys. So we're trying to like get ourselves engaged here.
I would say that I am interested in biological engineering because I want to go into like renewable energy research, specifically, or like environmental remediation, like maybe even like carbon capture, and I guess like the more chemical side of like biological engineering. When it comes to like cleaning up the environment.
Well, if you have any further questions, if my little short description of bioremediation at all piqued any interest, let me know, because we do a lot of stuff related to all of these things in this crossover between environmental engineering and biological engineering and natural resources. So it's, I think, an incredibly personally biased, of course, but lots of cool opportunities.
So I see some interest in biotech, which we definitely have a lot of, vaccines, medicines. So we have students that have gone to work on, I know we have students that go to Lilly. We have a student that's at Pfizer that is actively working on production of the COVID-19 vaccine. She has been hard at work. I think that's all she does these days is work, work, work. But I know she's thrilled to be doing the work. So we have a lot of students that go on to these types of things, and they are very well prepared to do these things.
Are any of you interested in pre-med? That seems to be a track that a few of our students are often interested in exploring, and there's kind of I guess some interesting context about how you might get there in BE versus like biology, for example. No pre-med? Okay, never mind. I was all ready to tell Dan Taylor's story about pre-med working in as a doctor and pre-med working as a researcher, but I guess you don't get to hear it now.
She teases us.
Like I said, I'm a little punchy. It's been a long day.
It has been a long day.
Well, the short story is that some students come into our program wanting to study biological engineering because they want to go on and become a doctor, but they love the engineering aspects. Then they get engaged in research, and they take the biotech course in the lab, and they learn all these really cool lab techniques. And then they realize, hey, I can, help people with cancer by being a doctor, or I can help people with cancer by developing the latest and greatest life-saving technologies to treat this awful disease. So they sometimes, as Dan would say, about, out of the 60 students, about 6 to 8 raise their hand that they're pre-med when they first come in as sophomores. And at the end, we have about the same number, but they're often not the same students. Which I found hilarious that they were not the same students, but it just goes to speak to the variety of experiences that you get in the program and how you can kind of find your way when you're passionate about a thing, but you're not exactly sure how to get there.
So I'm the student, just as totally changing the subject on y'all. A student has written they're interested in medicine, but specifically medical insulin for type 1 and type 2 diabetics. And so one of the nice things about this department is you find that we know so many people, including spouses or what we're all working on. And so the person who indicated that we'll have to sit down and have a cup of coffee, because that's what my husband had worked on tremendously. He was the person who helped develop the first inhalable insulin. And of course, it went to market and then through various things occurred. But he has studied diabetics and insulin for many, many years and could just talk your ear off about it. So if you ever want to get together and have that subject, there's a lot of good research, a lot of companies out there that are still trying to develop inhalable insulin versus folks taking shots for it. Pretty cool field to look at.
Diabetes was one of the reasons that I was originally interested in anything related to biology, but then specifically biological engineering. And what has been really awesome about this program is I've been able to pay attention to that passion of mine and sort of, you know, keep that sort of in the focus of my education, but also you learn about so many other ways that improvements are being made in other diseases, other medicine. And so it's a good thing to come in with a passion for a specific medical topic, but you end up learning a lot of it, like a lot of other stuff as well.
So the other thing I'd like to share with these students too is that you probably will hear from us in the future. We will stay in touch with you. We will be sending some emails and follow-ups in regards to other events that we hope to host in the future once COVID allows us to do that. We also have a in place right now where our student ambassadors are available. And Gabby, I'll let you elaborate on that if you want. But there is still a lot of opportunity for us to talk with you either one-on-one or in small groups. But throughout the next year and a half or whatever your time is in first year engineering, we will be reaching out to you to see if you'd like any additional follow-up. You are welcome to meet with any of our faculty individually and follow up with any other staff members as well as our student ambassadors. So Abby, if you want to talk a little bit about the setup the ambassadors have.
Yeah, so for the next, I believe, week or so, and two to three ambassadors will be sitting in the ABE building on the second floor, right above Copper Moon. We're sitting there for a couple hours, and you can either come up if it's not busy, we can give you a tour. If it is busy, we can give you a handout to do a walking tour of the building. We're also there to answer any questions that you might have, or just if you want to get more of a student's take on being in the program. I believe the list is posted somewhere on the official ABE website. I'm not sure. But it has which concentrations are which day and which times. I will be there on Wednesday, even though it's the reading day, we are still going to be there for a couple hours if you don't have a lot going on. Yeah.
So if you haven't had a chance to pop down to our new building, I mean, it's snowing now and blah, 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 but come on down, check it out. It is fantastic. I'm really excited to be in the building because for me as faculty, it's the first time I've ever been with my colleagues. I've always been on a building elsewhere on campus because that's where the labs were, but this is the first time that ABE as a program has been together with all the faculty and all the students, and it is just amazing. We are being really intentional moving forward with making sure we're having growth as a community, as an ABE community, both with students, faculty, staff, all of that. And I think it's just only going to make our program all that more enriched, and it's only going to make things better. I see students now all the time, and I never got to see them before because I just wasn't in the same building as them. And now I get to see them all the time, and it's great. I really love it. So come down and check out the building. It's quite colorful. It's great. It is colorful. I really like it.
It's color coded, isn't it?
It is.
It is
Well, color
color-coded.
coded and colorful. Each floor has its own color. And they're good colors.
There's some great wall art.
Yeah. Yeah.
No, I just everyone, to Gabby's point about the students leading the tours, I just posted in the chat the dates and times for those. So you can try to, put that on your calendars. 3 to 5 is when it starts to warm up a little, so you can, bundle up and walk around a little bit more outside. But yeah, it's great opportunity to kind of see where you could potentially be next year and help us break in our new building. It's a pretty awesome place.
We've got fantastic classrooms in the new building, really fantastic undergrad teaching labs. We have maker spaces, so spaces that students can just play around and run experiments. That soybean competition that Dr. Verma mentioned, we have spaces for students to participate in that. And they're well equipped, and we kind of give students, once they have the training, the safety training and some type of protocol, they can just get in and play around a little. It's their spaces, and I think that's really fantastic.
Mhm.
There's some really good study spaces as well. Copper Moon has outside of it sort of an atrium area that you can sit and do homework. And when we talk about access to faculty being very easy, that was true before we were all in the new building, but now I feel like every single one of my teachers every single day, and it's good because they get to talk to you, ask questions even about class sometimes. That's been really nice.
And like everyone's mentioned, we have a Copper Moon coffee shop right in our building. And today they had Mary Lou donuts. Huh? Yeah, I know. You didn't even know that.
All the snow and school canceled for all the little monsters, I did not come to campus today. And now I'm super sad.
No, it's all right.
Mm.
My waistline probably thanks me. As you can see, we're just a fun-loving group, so don't you want to hang out with us? All right, if there's any more questions, you guys saw the little QR code. If you scan that, fill that out. Lori will get your emails and connect you to our all the things that we have kind of going out, so you can get more information if you need to. Dan Taylor, if you go online, is an excellent resource if you have questions that you didn't think about, or you just kind of want to maybe talk to some faculty or in your area of interest and how the students are kind of finding careers and jobs in those spaces. I know we blasted through a lot of that stuff really quickly, but Dan can give you a really great kind of read on where some of our more recent grads are going, because I know that's often one thing that's really important to students is like, okay, so I get this really cool degree, now what kind of job can I have? And he's the one who stays in touch with a lot of our grads. We all kind of talk to our graduates in our own little areas, but he's got the breadth of everybody, so that's really helpful. And come by one of those times and check us out and see if there's any times you can see there. If those don't work for you, you can certainly send any of us a note. We're pretty easy to find. Oh, and Dr. Verma just put in the code if you want to go back and grab that. So with that, I think we'll go ahead and put up the final QR code, Andrew, whenever you're ready. And you get to register your attendance. And if anyone wants to stick around for a minute or two and ask some more detailed kind of one-off questions, we can stick around for a minute as well. And just thank you so much for coming, everyone. Really appreciate you taking the time on this snowy day.
Thank you for the presentation.
Thank you.
Thank you.
Yeah, and I have one more question. So I am interested in like pharmaceutical design, but specifically I really like microbiology and learning about microbes. Do you think it'd be better to like pursue the cellular and biomolecular concentration or the pharmaceutical?
I think that's a really great question, and that's something you don't even have to decide before you start.
All right.
So that's something like, and you might come in and take like the first, because I don't think you really need to decide until closer to the junior year. So you could come in and your sophomore year just as like, I'm not entirely sure. And that way you can get to know faculty and talk to them and kind of figure out which of those paths is going to work better for what you want to do. So you don't even have like, don't decide that right now. Like,
Okay.
yeah, I don't know.
And I'd say I'm on the cellular and biomolecular track, but pharmaceutical industry is like where I'm looking at. And I wouldn't say that I'm even hindered being in that, like it is, I still have the education to go to that field as well.
Let me say hi. No.
That is really cool to know though, Gabby, because I do think that
Yeah.
Mommy. I think it's an important point because regardless, you're getting a biological engineering degree and you're putting yourself in a great place to make your path, whatever it might be. And you might find that you do the cellular and biomolecular track and then you grab a pharmaceutical-ish, whatever that might be, elective that makes sense for you to do something that will help give you a little more context. But it's putting you in a space that you can really build your own skills as this, you know, really sought after degree, and it's giving you lots of opportunities. So
Yeah, and we take all the same fundamental courses, so you're getting the same very, you know, structured education that way. It's just some of the more interesting higher level classes. Yeah.
The other thing too, Hannah, I could offer to you to think about is eventually is we also offer what's called a dual degree track. It's in pharmaceutical processing and biological engineering. So it's 2 degrees and you're in both pharmaceutical pharmacy and ABE or biological engineering. Okay. So that is a 5-year degree though, but that kind of puts you in both those camps. But if you want to talk about that at some point later on, we can get together and I can show you the classes and along those lines. So we have quite a few students that do that as well. Okay.
Okay, thank you guys so much. This has been a very helpful information session.
good luck. Thanks for coming.
Yeah.